Hello everyone and welcome to the Midas Gen webinar for multi-material analysis and automated design software. My name is Adam Kane and I will be introducing you to Midas and taking you through some of the topic areas. The presentation is based around building information modelling, i.e. BIM, and the interaction between Autodesk software Revit and Midas Gen. If you would like to contact me or anyone in the UK support team, please note down the number and or email address for more information about the Midas range. So first of all, let's go through some of the how-tos and the use of GoToWebinar. I know that everyone can hear me and see my screen, but if you are having problems, please place your comments in the chat box on your GoToWebinar dialog box or call our technical support team. If your screen happens to go blank during the presentation, it will most likely be your screensaver kicking in, so if you can, please make sure it's set to off or wiggle your mouse. Thank you. You can minimize the GoToWebinar box using the red arrow in the top left hand corner. You can also ask questions throughout the webinar and I will answer them all at the end. So today we will be going through the following subjects. I'll give you a short introduction to Midas and also BIM, the interaction between Revit and Midas, moving on to look at a AutoCAD DXF file and how that is transported over into Midas Gen and built up into a model. Then look at the analyst capabilities, the results extraction, the design and the creation of the dynamic report, finishing the whole thing off by looking at Dshop, which is the automated drawing software package. So, just to give you a short introduction to Midas, we're the biggest developer and distributor of engineering software in the world. We have the #1 market share in terms of licenses distributed. Midas develops not only the structural analysis and design software, but also the civil and geotechnical software, as you can see on your screen. So if you or your colleagues would be like a bespoke presentation, please contact the Midas UK support team. Here I've captured a range of different structures. Midas Gen has been used on literally hundreds of thousands of projects across the world. Here we see the Burj Khalifa, the Moscow City Palace Tower, the Twin Towers in China and also the Beijing National Stadium. It's used for a multitude of different projects such as airports, blast furnaces and also plant structures. The projects depicted here are some of the recent BIM projects we have been working on in the UK, where Midas Gen is applicable for buildings of any size and complexity. So I'll now give you a brief introduction to Midas Gen. Midas Gen is an advanced structural analysis and optimal design system. It has an intuitive user interface much like AutoCAD for ease of modelling. It has state-of-the-art computer graphics and the most powerful solvers. There's a wide range of analytical capabilities enabling engineers and researchers to readily perform structural analysis and design for even complex structures. We also have comprehensive design to Eurocode and British Standard, and Midas Gen has all the major international codes built in to assist with any planned overseas works. Right, so now just a little bit about building information modelling. BIM provides the ability to share models between all professionals involved in the design team, which includes architects, structural engineers and MEP or mechanical, electrical and plumbing engineers. Each discipline of the design team can update the master drawing, which in turn automatically updates the central drawing. So here you see the interaction between the architect, structural engineer and the MEP engineering disciplines. The information is all communicated on one platform to create a seamless interaction between all parties. So if there is a clash between some of the services and the structural members, then it can be redesigned. As this is all carried out on one platform, the drawing can be updated quickly and efficiently. Revit is Autodesk's BIM product. It incorporates all the functions that the architect needs to fulfill the drawing design. The structural engineer, however, has to use an outside source to carry out the analysis and the design of the structure. Midas Gen can import and analyse any material and is being widely used in the UK by leading consultants. So Midas Gen has a good interaction with Revit Structure. Here you see the interaction. The multi-storey building shows that all the beams, columns, slab openings, foundations and materials are all brought over into Midas Gen. So here you see the direct link between Revit and Midas Gen. The dialog box appears and we have a few options like file location, units and material properties to be considered for the transaction. This is a very fast and effective way of communicating the model over to Gen. Here is some of the material we're going to cover during the demonstration. We'll discuss some of the issues with connectivity within Revit, look at the analytical model that must be present for the structural analysis and design to take place, then look at the Revit Gen interface, and I will show you what materials and sections have come across from the Revit model. I'll now just quickly take you over into Revit and we'll look at the working space. So here we have the Revit model. As you can see, it is a multi-material building. We've got all the foundations in the form of strip, foot and spread. We've also got a buried reinforced concrete earth retaining wall. We have the concrete columns supporting concrete slabs on the first two floors. And we have the steel for the top three floors in the form of columns and beams and also bracing. You can see we have a reinforced concrete shear wall. We also have a masonry wall next to it. We have the openings as well. And just to top it off, on the top of the building we also have the timber roof joist. Now what I want to show you is the analytical model. Now in order for anything to be analysed and designed, it has to be present in the analytical model. And we also have to have good connectivity. So as you can see from this column here, which is connected to the slab by a nodal connection, I purposely left out the second floor slab just to show you that how to make it an analytical, how to put it into the analytical model. So here you see the slab appears in the modelling space. We simply click on it and we go up to properties. We make sure that it is a structural element and we have enabled it in the analytical model. When we go back, we can see it is actually appeared in the analytical model. Okay. Right, as you can see, it's just appeared there. Now I'm just going to go up to the add-ins at the top, and we're just going to go to the external tool and send a model to Midas Gen. In a moment the dialog box will appear, which I explained earlier with the file location and the units, also with the codes you'll be using for the steel and the concrete. So we're just going to change that into meters. We've got the file location and also where the databases are stored. We can change that to the concrete, so we've got C30, and we can also change the steel as well. Right, then we just click the send button and we'll just overwrite it. Now it's just going to convert all those elements for us quickly, and then we'll just go over into Midas Gen and pick up the file. Okay, that means that's just sent across. Now we're just going to close down Revit. We won't save the changes. I'm just going to go over into Midas Gen. Here we have our blank working space in Gen. I'm just going to go up to File and just import a Midas MGT file, which is a Midas text file. Now we're just going to quickly go up to the Revit folder and import it. Now this is just a quick demonstration to show you exactly what's going to come across, and then I'll take you over to the DXF file and we'll start building that up. Now I'll just switch off the nodes there. Okay, as you can see, it's all come across. We have all our meshes. We also have all of our materials and all of our sections. So I'll just swivel that around for you there. So you see we've got all the foundations and everything. We have all the walls, all of our bracing, the steelwork and all the concretes come over from Revit into Midas Gen very quickly and easy to do. So now I'm just going to close that down and I'm going to take you back into the presentation and we're going to go through to the DXF file. So right, now we'll show you how groups are brought across into Midas Gen, how simple it is to drag and drop materials and sections. We'll now go into Midas Gen and quickly take the DXF file in its wire form over into the program. So I'm just going to go straight back into it now, and we're just going to pick up the DXF file. So just to explain that this is our work tree, I have already built up all the materials and all of the sections, including all the thicknesses. And I'm quickly going to show you how to do that. So we just go down to properties, go across the materials, and we've got them all listed here. So I just want to add one more just to demonstrate what we do have in the database. So we can select from steel, concrete, steel reinforced concrete, and we can also have user defined. We're just going to stick with steel in this case. We've got all the international codes from across the world, including the BS standard and also the Euro code, and we also have the extensive database for all the different material properties. So we're just going to add that now and click OK. So as you can see, it's just appeared there. I'm going to do the same for section just to illustrate how many different sections we have within the program. So same thing again, we've got all the codes from all across the world. We also have a variety of different sections to choose from, and there we have the different sections as well. So we're just going to pick up a beam and we're just going to click OK, and as you see, it's just appeared there. So that was just a quick demonstration of the materials and sections. Now I'm just going to quickly import the DXF file. So just go to import. I'm just going to quickly browse. Have to go up to the folder. Then we just import the CAD file. So as you can see, we have all the layers have come across. So we just bring those across into the model. We can select what material we want. We can also select if we want a different beam or anything, but we're going to define those all when we're actually in the program. Just click OK. So as you see, it's just appeared there on the screen. I'm just going to change this display quickly in the display options, just so it comes up with a decent colour. Okay. So we've just changed the colour. As you can see, we've got the groups here, and all the groups have come across. Now what I'm going to do, I'm going to use the groups and use the works tree and build the model up very quickly. So just going to make sure that everything's defined in concrete first. So that's everything selected there, and we just drag and drop the concrete over and just make sure it is concrete. Then we can do the same for the steel quickly. There you go, including the bracing. And just do the same for steel. Drag and drop steel, the material property goes across. We can also select previous, and we just select the universal column. Just for the bracing, we just want to make sure that is the actual CHS tube. So we just pick the bracing across. We can do the same for the timber at the top. So we just want to select the timber roof joist, select timber, drag and drop. It's all a very quick and simple process. So now we're just going to focus on the strip footing. So we just double click, make sure we got the strip footing selected, and we just take that into working space. Now I just want to select the pad footings at the base, and we just drag and drop them. We can use different isolation functions as well, so I just want to make sure that the mat footing underneath the shear walls and also the stairwell is a 450mm thick footing. So we just select all, and we're going to use the auto mesh function for this. So we just go down to auto mesh, and we just make sure we select a different thickness, call it foundation, and just click apply button. And then we come up with the mesh, and the thickness comes in as well. So we just go back to the original wall. Now what we want to do is make sure that we've given walls, and we're just going to focus on the bottom floor for this. So we're just going to go to the side, make sure we've got everything selected. We can press F2 at any time just to make sure we activate it. And now we've got all of the bottom floor isolated. Now we're just going to use the auto mesh function and select by plane. We know that it is a 300mm thick retaining wall. It's called retaining wall 1. Then make sure we just select by plane for all of the walls on the bottom floor. So we're just going to, and you see it just highlights it quickly. We can just click apply. And we do that all the way around, making sure that we just change it for the direction we want it in. Just click apply again. Okay, I just want to make sure that we get this on the angle, so we've got to select by the 3 points and just click apply. Now what we want to do is just quickly do the walls on the interior. So we're just going to make sure that we can activate those. So we just select them. Here we go back to the original view. Do exactly the same with the plane. But we know these walls are, some of these walls are retaining walls, and some of them are actually the masonry walls as well. So we can just select it, and we just want to shear wall 1. And we're just going to put them all as the 225. So just click apply. and it will even account for the openings in the walls as well. So let's do that just one more time. Click apply, and it takes account of the actual shear wall opening. So just select that on the other two planes and apply, and then once we've done this, we'll just move on and we'll just do one of the slabs. Then I'll go on to show you the full model once it's been complete. So as you can see there, we'll just reactivate everything and do exactly the same thing again, and just do the first floor, and there we go. So I have a 200mm thick slab, select all, and just click apply, and it will take account of all of the openings within the slab as well. There you go. And just a couple of minutes, we've just managed to do the whole of the bottom floor. We've got all the steel at the top floor, and we've also got all the timber, and it is very quick and easy to build up. So now what I'm going to do is I'm going to close this, and we're going to go on to the loads and boundary conditions. So from the previous demonstration, you've seen some of the different material types and sections that have been brought across and built up into a model. The main focus of this next section is to look at the implementation of some of the loads and boundary conditions. So what we're going to do is going to look at the hydrostatic pressure and also the boundary conditions at the bottom of the structure, and then some of the pressure loads on the floors and some wind loading. So I'll take you straight back into the modelling space. So here we have our next model, which is load definition. So what I'm going to do now, I've created a group for the buried wall structure. So we're just going to quickly select that. Right. And we're just going to apply hydrostatic pressure to this model. So we're just going to load hydrostatic pressure loads, and we can just select some of the parameters. So we know that the height of the soil was 3 meters from the ground, and we can change the units every time. So I want to work in kilonewtons and meters. So we just change the constant intensity to 10 and the gradient intensity to 5, and we just select all and click apply. And as you see, you can visualize the actual the hydrostatic pressure load at the base of the wall. Now we're going to do some of the boundary conditions as well. So the surface spring supports for the structure. Activate everything. We're just going to select by plane. So we only want to put the boundary conditions on the bottom of the building. So we just select that. Go to close, and we're just going to look at the boundary conditions. And we're just going to focus on the surface support. So we just want to go in some of the modulus of subgrade reaction. So we just put in some of the values there. We just click apply, and then you see all the boundary conditions come up. These will also appear in your works tree as well. And you can just click on properties, and you can manipulate them again. Okay, that was just the boundary conditions. There's also the hydrostatic pressure. Now we'll just put a pressure load on one of the floors. Let's go to load, pressure load, and we got all the load cases as well, so you can put it as in dead load, live load, change it to whatever you want. Simply we'll select by plane. We'll just select the second floor, and we'll just go for the dead load. We'll go -2, and we just click apply. And as you can see, visually it comes up very graphically. It doesn't matter how many times you zoom in, it will just keep on going more and more detailed. We do the same with the live load as well, and we can just select by previous and just click apply. Okay, right, now what we want to do is just show you the wind loading. So we just go to load, lateral loads, and wind loading. All the wind loading is done automatically as per the code, so we want to go in the X direction. We just want to select the Euro code, go in the X direction and not the Y direction, and just click apply. We can also look at the wind load profile as well. We can look at the story force, shear force, and also the overturning moment. You can also look at the calculation sheet as well. We'll cancel that. But there's the calculation sheet comes up as well for the wind loading across the building. So we'll close that, and as you can see, you get the visualization in the background. Right, now that I've shown you some of the implementation of some of the loads and boundary conditions, we're going to move on to look at the analysis and design. So we're just going to close this model down, and we're just going to click no. So just move swiftly on. So Midas Gen has superb graphical representation for its results. I will now take you back into the program to show you some of the bend and moment diagrams, reactions, the deflector shape, and also the contour plots. So we'll just go quickly back into the next model. So here we have our model. Now we're just going to, the first one thing we're going to look at is the reactions at the supports. So we'll just do it under the live load case, and we'll just leave on values and also the legend. So we just want to look at the maximum, and it will just indicate where that is. So click OK, and we'll get those reactions at all the supports. Okay, as you see, we have our legend down the side, and it tells you where the maximum moment is happening. You can also look at where the max is happening here as well. So now I just want to show you quickly a results table. You get results tables for everything, and they are all 100% Excel compatible. So we just look at results table for reactions. So we just want to look at it for the dead load and the live load. Okay, and as you see, we get all our results table here. We've also got the auto sort functions within the program. So if you do want to say that you look at the worst case for FZ, you pull it across and you just put the priority up to the top. And just click the sort button, that will sort it out for you. You can also take this information, you can copy it as well into a Word document. You can take it into the dynamic report at the end. You can also save it into the dynamic report here, and you can select any of the different functions and click OK, and that will be saved into the dynamic report. Just click on close on that. Now we'll look at some of the displacement contours and the deform shaped. So we'll just look at the deformation, we'll take off the values, and we'll just click apply. So here you see you get good visualization of the results and also in your legend, and you can get this all in the table format as previously mentioned as well. So now we're going to look at some of the bend and moment diagrams for the steel. So we'll just pick up the sections, and we'll just click on the materials and just select steel. Just activate that. So we just want to look at the bend and moment diagrams here. Don't worry, it is a bit of a mess now, but it will redraw itself when we take off the deformation. When you get the bend and moment diagrams, you can look at them in two shapes. You can also look at them in different planes as well. So if you do want to select by plane, then you can. You can just isolate that, and you can just look at them as that plane. Okay, that's just showing you some of the bend and moment diagrams. Obviously, you can look at all the values in these in the tables as well. And we'll quickly just reactivate everything. Okay. I'm quickly going to isolate a slab so we can look at the plate stresses as well. So here we have one slab. We'll just look at the plate stresses. And just click apply. And here you see the plate stresses as well. So I'm just going to take you back into the presentation and look at some of the design aspects of it. Okay. So now I'm going to show you how to automatically design some of the elements listed here on the slide. We'll take you back into the program. We'll look at a reinforced concrete column. We'll also look at the steel design and briefly look at the optimization. We will then look at the slab design and also the wall design. So you bear with me, I'm just going to go straight back into the program and start that process again. So here we have our model. We're already in the analysis, and I just want to select one of the members here. So I'm just going to select this member, and we're just going to show you how to design that. So the member is selected, we just go out to design, concrete code design, and also column design. And we can look at our NM interaction curve, and also a summary report and a more detailed report. So we're just going to look at that member now. So just look at the PM curve or the MN interaction curve. You can manipulate that and look at it from all angles. You can also have a graphic, which is a summary report, which has all your actual forces and moment capacity checks. If it's highlighted in red, that means the section is failing. You've also got the MN interaction diagram here as well. We can look at a more detailed report, and you can check as per the code exactly where it is, so where it's been selected from the code, and you can also check the calculations. So we just go back from that. We just want to destroy that as well. Now we're just going to quickly look at the steel design. So I've created a group for just one of the bracing column and also a beam. So we're just going to quickly isolate that now. As you can see here, we have those on screen. So what we do, we just select all, and we're just going to go up to design, and we're going to go to the steel code check, and as you see, all the elements have just appeared. So it will give you the universal beam, universal column, and also CHS tube. So you can look at these all in the members, and you can look at the graphic for the summary report, where it will give you the actual member and also give you if the section is failing as well. And you can also, much the same like the concrete, you can look at a detailed report. If you do wish to change any of the members to find a more satisfactory section, you can go up to change, put in some of the parameters, and it will find a satisfactory section for you. We're not going to do that now, but we could show that in another demonstration. What we'll quickly show you as well, if you would like to do the steel optimization, you can go up to design, steel optimization design, and you can select all these members, and it will select a member by weight, and you'll get a result much like the PDF document I'm about to show you. So once you've carried out the design analysis, you'll get a report like this one, and it'll give you, for example, you've got the 203 by 203 by 60, and it's changed it by weight, so it's 203 by 203 by 52. It'll also give you the saving of the weight and the total weight as well. Just going to close that down. We're just going to close that. Now what our main focus is going to be on is the slab design. Just get everything back up on the screen. I just want to select one slab. Just close that. Let's do the slab flexural design. So we just select it. Now what we want to look at is we want to see the rebar. We can also do the wood armor moment if you have got reinforcement going in different directions. Just click the apply button, and we're just going to look at the reinforcement, and this will appear in the worktree. So I'll show you out in the worktree in a moment, along with the column as well. Right, so here you see the reinforcement. We've got displays, so you've got the P12s at 300s in the bottom, and we've got the P12s but at 100 sensors in the top. What I'll show you now is I'll just show you in the works tree when it's been updated. So first of all, I'll just show you the mesh slab. So here you have it where you've got the reinforcement is displayed, and it tells you exactly what sensors it is. So you can go down to properties, you can manipulate that, you can change it to whatever size you want from the drop down. So add rebars and take them away, etc. So we just close that. We've also got the same for the column as well, that I didn't show you a moment ago. So you just go to properties, you can manipulate it, and you can change to the reinforcement you want. You can also change the shape and size and everything. So we'll just close that down. Now we're just going to show you the shear check. So slab shear checking, just click the apply. So we have the slab shear checking, and you've always got the values with the legend as well. Now we'll quickly look at the slab serviceability checking, and we'll look at the crack control and the crack width, and then we'll just quickly look at the deflection. So we'll just click the apply button. It'll just take a couple of seconds. I'm just going to take you back into the presentation and show you, because this does take a couple of seconds, I'm just going to take you back into the presentation and show you the tables and also the dynamic report, which I'm going to do at the end. So we'll just take you back there now. So I'll now just show you and explain some of the table features and also the dynamic report. So I've shown you a few tables in Midas Gen. and we'd just like to outline that they are all 100% Excel compatible. The tables are made available for all the analysis and design results. It has powerful built-in filtering systems for various selection functions where finding the worst case, for example, is made very simple. There are a magnitude of different editing functions where you can copy and paste anything to the clipboard and the dynamic report. So you can also get a bill of materials from Midas Gen, and this is automatically made available in your dynamic report as well. Here is a dynamic report feature where you can upload anything into the reports tree, like tables, graphs and pictures. You can then simply drag and drop them into the Word document within Midas Gen user interface, and I will show you that after we've just completed the design. So we're just going to go back into design. There you go, you can see that we've now got the crack width values have just come up. We'll just look at the deflection as well. You can also just do the deflection, just click the apply button. This will take a couple of seconds. There you go, there's deflection. Okay, now I'm just going to go on to show you the shear wall design and also the buried structural wall design. So you just reactivate everything. Okay. Just take a couple of seconds to come back up again. So just click the on the buried structure. So it's a very quick and simple process to design these. So we just go up to the design, go to mesh and wall design, and just go to wall design, and just use all low combinations. We just look at the rebar. In fact, we're going to change this so it goes a bit quicker. Just going to click one of the low combinations and just click apply. Very quickly go through that, and all of the rebar will appear in the works tree. So you go, it's just carry out a design on that, and as you can see, the mesh wall design and it's all appeared in the works tree there. Okay, that was just a brief snapshot. Now I want to show you the analysis that could be carried out on the masonry. So we're just going to go into the next model. I'll just quickly show you masonry. So what I've done here is I've isolated the masonry structure in the middle. We're just going to look at the plate stresses and also the yield points where we've got the crack formation. So we just click apply. As you see, you can graphically see all of the crack formation, and also I've got the deformed shape on as well, so you've got the detailed crack formation of the structure. Right, that was just a quick snapshot of the masonry analysis that can be carried out. Now we're just going to move on to just the report. So here we have the model in my dynamic report generating space. So if we go to the report editor, as you can see in our report tree, we've got all the images, bending moment diagrams, everything there. So if I just drag and drop a few of the images, it's going to take a couple of seconds just to come across. You can obviously edit anything within this working space because it is Word. Sorry, just want to change the units to millimeters. So I saved everything in that. Let's do exactly the same thing again. Okay, there we have one of the images just come across. We'll do the same with some of the bending moment diagrams and everything like that. So just the reactions table, we'll just drag and drop that. It will take a couple of seconds. So as you see, the reactions table has just come, the reaction picture has just come across. We can also take the table as well. So we just go for max reactions. We know where they are, so we're just going to bring them across now. See, we have our table. Midas Gen automatically builds it all up for you as well. So if you've got to define text, it gives you all your boundaries, all your nodes and everything, so you can also copy and paste them. We were talking briefly earlier about the bill of quantities, where you can drag and drop that across. It'll give you all the values of all the different materials that are used. Okay. You can also just get that from the top as well. So if you go to the tools, you can look at the bill of materials. It'll give you a basic bill of materials for all these materials. Okay. There you go. There's your bill of materials as well, and it'll give you all of the the quantity of steel and everything that's been used. Okay, now I just want to show you how dynamic the report is. So what I'm going to do is just go back into the modeling space, just delete a few of the columns. So just select those, just delete this column here, delete this column, and possibly this column over here. Just press delete. Analysis results, design results will be deleted, but that we don't mind about that. Now we just go back to the report, we go to tools, and we just auto generate it. And it will give you a dialog box saying exactly what needs to be regenerated. You can click OK, and then it will automatically be regenerated for you. As you can see, it's been regenerated. So that was just a snapshot of the dynamic report. Now we'll just go back into the program, and we'll just carry on. So now I will show you Midas Dshop briefly. So Midas Dshop generates structural drawings. The export from Midas Dshop can be in DWG or DXF format, so you can take it straight over into AutoCAD. It gives you layouts of the reinforcement, as you can see here. It can give you the reinforcement detailing, automatic placement of reinforcement bars reflecting constructability. Dshop also checks for the clear spacing of rebar as well. It automatically generates the general notes for your drawings, and it will give you a bill of materials automatically as well, displaying the reinforcement of material quantities for construction using the design results. It will give you the framing plans for both steel and concrete. It will give you beam reinforcement detailing, and it will also give you a members list for beams and column layouts. So that's just a snapshot of Dshop there for you. So just to finish and recap on the advantages of Midas Gen, it can analyse multiple material types within one working model. There is no restriction on element types and connectivity. For example, the bracing will automatically find whether it is in tension or compression based on the loading criteria. There is no restriction on the complexity of the model within Midas. The generation of structures of differing complexity is very fast and easy to learn within the program. Midas Gen has an interaction with Revit for fast and effective design and analysis of results. The analytical results are of the highest standard and all come in table format and are 100% Excel compatible. Midas Gen has fast automated design for functions built in to Eurocode and BS standard, and it is a high-end finite element analysis package. It can carry out analysis in either solid or shell elements, and can carry out detailed connections analysis and compression chambers, just to name a few. So, first of all, I'd just like to cover some of the questions that have come in and request that any other questions be posted now.